Okay, hello everybody, and thank you for taking the time to join today's webinar on simplifying phased array weld inspection with custom apps. I wanted to open up by mentioning that there's quite a few people on this call, and so if you have any questions you'd like to ask during the call, we certainly welcome them. We want to get to all of them, but we ask please just type them into the chat window, and then we'll address them at the end of the presentation to allow us to get through the material here. But we did build in some time for that. We do appreciate the questions, so please add them as we move along here. I'm Matt Skinner, and I'm a Senior Product Manager with GE for this platform. I'm joined today by one of our Senior Applications Experts, Dan Groniger. Dan, I want to say hi.
Yep. Good morning, everyone. Welcome to our webinar.
So what are we going to talk about today? Today we are talking about inspection apps. And in the NDT community, in the inspection community, when we say application, we all think of inspection applications, whereas the rest of the world, when you say application, they think of iPads, they think of apps. And actually today we're talking about those types of apps for the types of applications that we do. Specifically here, it's weld inspection. But we wanted to go a little bit into this new concept and talk about how and why it was developed and address some of the possible benefits that you could find in this type of approach to inspection. We're going to give you a demonstration of an inspection app. In this case, it'll be weld inspection. And then we're going to demonstrate a little bit how to build a custom app. Because I know that statement right there, to some people, I know to me, if you said you need to build your own app, I think of my tablet, my smartphone, and I don't know how to build an app. So we want to get into a little bit of how we've made that possible with this platform. So the power of custom apps, or why we decided to go down this path with this platform. As we know, any inspection that we want to do is going to require certain steps for us to perform a valid inspection. If we don't take the right steps before the inspection, if we don't set up properly, then the results we get in the end, they're totally invalid. So with that in mind, we as an industry today, it's a common approach to get our equipment together, deploy to some location, and either before we deploy or even maybe once we're on site, we get in a comfortable space, we'll create a setup on our instrument, and we'll save those setup parameters as a file. Then when we get out to the asset to inspect, we'll recall that setup and we'll inspect, or I guess more accurately, we'll collect our data, and then of course we'll do the analysis and therefore provide an inspection. So what's new about this and the new approach that we're offering today is the ability to actually create an app specific to that inspection, and this can actually save time, especially if you do a variety of different inspections, because when you get into the field, you simply recall the app, just like you do on any app you use today on a device outside of inspection, and you follow the app, and that's going to allow you, with all of the environmental variables we encounter in the field, to stay on point, to stay true to the steps we need to follow to have a valid inspection. And so the app itself is really just a custom user interface to the device. In our industry, we have a lot of specialized devices, and that's exactly what they are. They're just a custom user interface. So this goes a step further, whereas you have one instrument, and you can customize this user interface, or you can customize it for your technician. So you know the screens they'd be looking at, or you'll be looking at as you do an inspection. If there's any validation steps, you want to make sure they're performed. If there's certain data views, maybe they're looking at an asset from a certain point of view, or whatever you want, you can define that in that user interface that's pertinent to your inspection application. User-defined readouts, these are simply the measurements. In ultrasonics, maybe a specific gate, or a gate-to-gate measurement that you want to be on the screen. You can define all of that. So while we are talking about weld inspection today, this concept applies across any ultrasonic application. So keep that in mind, think broadly, and we'll continue to move on here. Just some cornerstones of this concept. First, we need a fully capable inspection device. We still need the probes and the scanners and the electronics to do what we do. So that's definitely a part of the concept. We also felt it was important that this device be connected for remote collaboration during the steps of the inspection. This could be, during the setup or while you're collecting data or even during analysis. And we've built in some mechanisms to allow that remote collaboration. And then finally, we felt it would be important to have this compatible with, all of the variety of scanners and probes and analysis software packages that are out there. So overall, this is not a forced ecosystem inspection package. This is very open. It's very flexible. And even the inspection app that we're going to walk through has a great amount of flexibility, allowing you to tailor it to your needs. Some perceived benefits of this system. Number one, it's going to decrease the learning curve of our inspection community. And that can be looked at as the learning or even the relearning curve. If it's an application that maybe you don't do every day or on an asset, we have so much flexibility here. We can put a picture right down to the location you want to inspect in the actual user interface of the device just for that inspection. So when you come back to that asset, you see exactly which way you've decided to scan or any parameter that you want to be real specific on. This, of course, is going to provide for consistency across the inspectors that are collecting this data. If we set up the same way and we collect the data in the same manner, we have a greater possibility of ending up with consistency and taking out some of the variables that are inherent in what we do. That is also going to increase the reliability of the data. And then finally, we can apply our expertise broadly across the organization and even across the industry. There are some very specialized inspections that are done and a very small population of people that we all agree do it very, very well. And so while they get a lot of air miles, on the one hand, it can be a time constraint when we just have a small population of people that are capable of doing certain inspections. So using this app concept and the remote collaboration feature, you kind of get the capability to be in two places at once. So now we're going to move to the live demonstration, and I'm going to pass the ball, if you will, to Dan Groniger.
All right, we have set up here on your screen. You can see on the left camera looking down on my equipment setup. I have my Mentor instrument, I have a scanner, probe, and wedge. I have the familiar IIW Type 2 block with 2 radii that we'll use in calibration in a little bit, and trusty bottle of coupling. So we can launch the app several different ways. The quickest, if I've already run through this and set up previously, say I've done all my calibration steps back in the lab, I'm out near my pipe, my weld, and I'm just ready to inspect, I can launch the app and resume where I left off. And that's going to take me to the panel that I was on and the setup that I had the last time I closed that app. And when it fires up, we'll see that we are all ready to inspect the weld. I have a sample here that's about 3/4 of an inch thick. I have a weld that's filled up out of several passes along the length of the weld. In this area, there's a crack or a lack of weldment down at the base of the weld, at the bottom of the V. In this area, there are some inclusions and porosity in the weld in the center. And right along here, there's a surface breaking crack right at this edge of the top of the weld. So I'm all set up. I've got my scanner calibrated. My instrumentation's all calibrated. As I scan across, we can see on the C-scan on the instrument, there's the lack of weldment at the base of the V, the inclusions, and the surface breaking crack up near the top. And I can scan back over that either direction. So that method was coming in, just resuming where I left off the last time. I can also launch the app. And launch is already selected by default. And here we can see for the first time, the first couple of panels of the app, but I've already saved the setup. I'm just going to say load settings. And it'll restore all the parameters that I saved. So very similar to a phaser instrument or a traditional ultrasonic instrument. I can create a setup, I can save it, and I can reload that at any point just with the load settings. In my settings, so in my save settings, I had slightly less gain selected. So you see the image looks slightly different, but we still see, just like last time, select weldment, the inclusions and porosity, and the surface breaking crack. Okay. Then yet another way to start up the app is to simply launch the app, but this time rather than recall settings, we are going to go step by step through the entire process of calibration. And that's where the IIW Type 2 block comes into play. So the first panel of our app is sort of a welcome, little introduction to the inspection. On the second panel, we've chosen to include a parts list. Here's everything you need to do the inspection. The probe, part numbers, wedge, cal block, scanner, and we're going to go step by step. Here's sort of a table of contents to walking through the calibration process. Okay. So the first step in our calibration is we are going to check our probe for dead elements. I'm just going to wipe off the wedge. The instrument has set itself up to scan a one element at a time along the length of the probe. It's a 32 element probe, and all I'm doing is just straight shots from each element to the face of the wedge. And gain's a little bit hot here, so I'm going to drop the gain. All right. Do calibration, and it says, as you can see, all of the elements are alive and working. The sensitivity variation from element to element is within the acceptable limits. So where the probe's good to go. Next step that we're going to do is we're going to use the two radii on the IIW Type 2 block. This is just a general setup panel, an opportunity to make changes. We're going to skip ahead to our velocity calibration. Now, here's where we're going to use the two radii on the IIW block. There's the 4-inch radius. I'm going to slide over a little bit to begin to pick up the 2-inch radius as well. Now what we're going to do is I've told it previously when I built the app, I've let it know that I'm going to calibrate on a 2-inch and a 4-inch radius. It's already positioned gate A at 2 inches and gate B at 4 inches. And it's going to prompt me select the 2 inches of the 50 millimeter. Hit the cal button and cal button again at 4 inches. And it tells me I've measured 3,217 meters per second velocity, which is right at the expected velocity for shear wave and steel, which is what we were trying to accomplish. Okay. On the next step, we're going to establish an even sensitivity across the base of the probe. And for this, we've told it we want to set up on the 2-inch radius, 50 millimeter radius. See, it's already positioned the gate around that. And when I hit calibrate, it will set the sensitivity, the gain on each individual beam to give me the same amplitude on every beam. Okay. Next step, we're going to do a simple 2-point TCG calibration. And here's where we can introduce the ability to make some changes to a couple of our parameters as we set up. I'm going to widen my tolerance just a little bit here, make it slightly easier to get through the TCG calibration in a timely fashion. On the top of this screen, you see what's called the amplitude view, and you'll see a red and a green line on that amplitude view as I scan back and forth over a hole that is 18 millimeters deep. To widen my gate out just a little bit. You can see that hole moving very faintly back and forth. I'm going to change the gain up just a little bit to start. Okay. Hit the cal button. Move back and forth over the hole. Now, I scan back and forth. I'm getting the maximum amplitude on each one of the beams. And we got our first point. Change to our second point, which is a hole at 30 millimeters deep. A little bit more coupling on here. And that's the second TCG point. Now, our sensitivity calibrations are complete, and we would like to calibrate our positional encoder. For this, my weld sample here is 147 millimeters from front to back. I've given the app and the instrument, when I built the app, a rough idea of the number of ticks per millimeter that my positional encoder is going to give me. But we can calibrate that very precisely. If we know that it's 147, got a little pointer here. I've told it at the top the expected distance is 147. If I hit calibrate, move the scanner the defined distance. Hit calibrate. Move back to 0, checking for backlash. And it says scanner's good. Backlash was minimal. And now if I move, there's 0. I move to the other end of the part. It's 146, 147 millimeters, back to 0. Okay. At this point, we're ready to scan. I will drop the probe down on this part. And this is our basic inspection panel. Do my scan. Okay. If I wanted to, if I'm making a record of this, I can clear. I can hit record. Do my scan. Stop recording. At this point, I can save my data if I like. And I can recall this scan later. I can analyze it here on the instrument, or I can take that data set file to a PC where we have available a PC version of the software that runs the instrument. All the same evaluation techniques are available there. So you can analyze the data that you've collected with the instrument offline if you choose. Some other handy features for analysis here in the instrument. If I draw a box on the screen with my finger in the C-scan, whatever I've drawn within the box here is visible in this zoomed-in view. Again, draw my box. The zoomed view shows what's going on inside the box. I can take any of these views maximize them on the screen with a double tap gesture. Here, if I draw another box on the zoomed in view, I have various parameters that are displayed, measurements. I can move the crosshair around. Whatever the crosshair is pointing to is indicated with readouts at the top. If I move the crosshairs around here, you'll notice that the sector scan is updated based on the position of the crosshair, as is the A scan. So the A scan is going to show you whatever is directly under the crosshair. The sector scan will show you the sector view that matches that position as well. With that, that is our demonstration of the app running on the instrument. So Matt, back to you.
Now that we have actually seen an app being run and followed, let's get into how we actually build and customize apps. This is, of course, the next section of our webinar per our agenda. And so the best way, or a good overview or way to consider how we build apps would be very similar to PowerPoint. If you could imagine creating a PowerPoint to describe your inspection application, that's very similar to the way that we build a custom app, and obviously that would be quite a bit different than being a full-fledged, software developer that builds apps for the general public. So I would want to point out, this portion may be the only time that some of you ever see this. It's totally feasible that all a user ever does is follow apps that are built by others. We just want to go into how they're built in the event that either that user wanted to make a change, or just so you understand a little bit more about what goes into building them. So what you're looking at on your screen now is a software program called Mentor Create. This program comes with the system. It's not an extra charge or anything, and it runs on your PC. It's a very intuitive platform, especially the second time you use it. And I want to point out that the apps that we're going to create, these are less than 1 megabyte. So they're saved as a file. They can easily be emailed, saved, archived, whatever you prefer. So when we build an app, there's a little bit to be described around why we might build one. And that's really up to the user. It can be as flexible as the user wants it to be. On the one hand, you might just decide to build an app that operates very similar to a device that you have today, or maybe one that you had in the past, and it's not specific to any one application. It's got all kinds of flexibility and control in every parameter of the inspection, and that's how you want to set it up. And if that's your prerogative, then that's fine. Kind of the next step down might be you may decide to have apps only for weld inspection, per se. But those apps may not have some of the parameter controls that you would need for other types of inspections, maybe corrosion inspections or composites, something like that. But for pretty much any type of weld, every control you want could be in there. Maybe the next step down would be only specific types of welds, plate versus pipe. And then finally, you could get all the way down to the level of a specific app for a specific asset. So sky's the limit, really just up to the user as far as how and when they want to build apps. So obviously, one way to do it is to just build a new app. And to do that, we come up here and click on New. We'll give it a name, and we'll call it New. And within our new app, we come over here, and we've got the general information. We can put an author, company name, any comments, a place to put that. If we want to lock this app, so once we get it built, it can only be changed with a password. We have that capability here. The app itself actually has pages, right? And we call those panels. So in order to start it, we're first going to add a new panel. And so we're going to, this panel, our first panel, maybe we want on our app a title page. So this would be a title page. And on our title page, perhaps we'd like to have maybe some text, and maybe an image. So we'll put those two boxes on here, drag them around, put them where we want them. We'll add our text. And then we'll highlight it. You know, we can make the text whatever size or font, or you know, we can really make it look how we want it to look. Might have made it too big here. Yeah, I made it a little big. That's okay. There's our new application. Maybe we want to bring a picture in. We'll just grab any picture here. All right, so here's our title page for our new app that we're going to build. Next thing we would need, perhaps we want to put in some instructions as to how this inspection is supposed to be done. Or actually, maybe we have a PDF that we want to use. So we would just add that PDF directly here. We would import the PDF. I actually don't have one ready to import, so I'll put a little text over on the side as well, just so we remember what this page was about. These are instructions for this inspection. Again, we'll make it a little bigger so we can see it. And maybe our next panel would be some calibration type panels. So we'll add a new panel, and panel 3 here we'll do a dead element check. And so this panel will be a calibration panel for checking dead elements. And maybe when we're checking dead elements, we would like to see an A scan and an E scan. So we'll put those on there. We'll just give it some generic names. Again, size them how we'd like them to be sized. Place them where we want them to be placed. And maybe we'd also like the ability to control our gain on this particular panel. So we can come in here and drop a gain control box. Now, when we're on this panel working with the dead element check, if we need to adjust the gain, we will simply be able to open that up and adjust it right there. So our next panel might be, say, another calibration. Let's say we do a delay calibration. We'll call it the delay. And for this panel, again, we'd like to see a scan and perhaps an E scan. Actually, we'll just use the same ones we used already. I'll add them over there. But because this is a delay panel, we would like to have our, let's put our reflector type. Our reflector type and position that we're actually going to use for our delay calibration. Let's put the probe delay value as well. So we'll put these on, Ref1, Ref2, reflector type, add all those, it stacks them up. You know, we can align them however we like. And there we go. So we're going to be calibrating our delay. Put in our reflector or a reference value of what we're aimed at and what type of reflector we're going to use, whether it's a radius or a side drilled hole or depth measurement. Maybe for our final calibration, we're going to do a velocity cal, but this time instead of building a panel from scratch, I've got this little clone button to this panel. I'm going to use that to add my next one. So now I have an exact copy of this panel. But instead of calling it a delay, we are going to call it velocity, and we will change the type to velocity. And we no longer need to see that, but maybe we'd like to see the velocity cal type. so we'll go ahead and add it. All right, so once we've got our calibration panels set up, we'll put our final panel in. This will be our data collection or our scan panel. We'll call it just that. And on our scan panel, while we're collecting, we'll have an A scan, an E scan, a C scan, and just use generic names for these for now. Again, set them up how you'd like to see them. And there you go. So we've just built a custom app with, I don't know how many panels we added there, 5 or 6 panels. We have our cover page, an instructional page, a dead element check. Oh, actually we have 2 dead element checks. This panel we didn't need. Dead element check, delay calibration, velocity calibration, and then we scan to collect and save the data. Now we did that very fast, but then the reason we did that very fast is because this is actually the less common way to build apps. So now we're going to get into another method to build apps that'll get into more detail around how they're built, that I think is going to help understand one of the real benefits of this process. So I'm going to go back out here to the home screen, and I'm not even going to save that one. And because what we do often is so similar, if we do a weld inspection, there are steps like the dead element check that we take all the time. It is probably more common that we'll take an app that we already have or someone's already given to us, and we'll simply clone it and make the modifications that we want to make. And this is where the concept of building an app for a specific asset begins to take shape, because if we were to really reprogram every instrument for every asset we're going to inspect, we would never get anything done. So to get into the concept of cloning apps, I'll go to the one that Dan used for his demonstration here. And I just hit the I there, I hit clone, and we'll call this Tuesday. And we will clone it. And now we have an exact copy of the app we saw Dan do his demonstration with, or another app that's out there, but we can modify it all we want, make any changes we want, and we don't have to worry about losing our original app that we might have spent some time creating. So now that we have this cloned app, let's say we generally liked everything about the original app. There were just some minor changes we want to make. Maybe we're going to use a different probe for this inspection, so we could change any of these details here. We would just right-click, delete that image, bring in another one. Right-click, retype the text, make those changes. Maybe in the data collection portion, one of the things that Dan had decided to do was have the zoomed window on the screen as well as the full C-scan. Well, maybe we don't like that. So we can just delete that zoom window, delete the associated description box here. And whoops, I didn't mean to delete the E-scan, but actually I can go up here to the right corner, hit the undo button, it comes back. I can resize my C-scan. And let's say that in addition to this, we'd like to be able to see another panel that gives us our amplitude C-scan as compared to a time of flight C-scan. So I'll just clone the scan panel here. Now you can see I have two exact copies. I'm going to actually take everything off of my copy, except for my amplitude-based C-scan. And then above it, I'm going to add another C-scan. We'll just let it generate a generic name. And I'm going to send this to the back. And that's just like in PowerPoint, where you have an image and you can overlay the image on top or have it behind. So our data source for this top C-scan is currently an amplitude. We'll change it to time of flight from our A gate. And now we have a time of flight a time of flight C-scan from our A gate that will exist right above a amplitude C-scan from our A-gate right below it. So we'll have the ability to compare the two. We'll go ahead and rename this panel. We'll just call it Scan 2 so we remember to know the difference. But obviously it's pretty obvious when we move between the two. So once we have all these things done, we can save it. And then we would just build it, which takes it through the write process. And you can tell it, do you want it to start from the first page or start from the last panel that you opened, give it some behavioral criteria. And from there, you've got your app built. And that's really all as far as the demonstrations. Again, in this amount of time, we just want to give you an overview of the concept, how we use apps basically on the system, and then also how we would create some apps. So I hope there's some questions, and we'll be happy to take them now.
Okay, thanks, Matt. This is Julia Wilson. I'm a panelist here. So we do have a question. The question for you, Matt, is in my job, I encounter a wide variety of specialized applications. Do I have to create an app for each application I encounter?
Thanks, Julia. So yeah, that's a good question because it can be confusing. I guess especially with the general knowledge of what an app is in the broader sense, you kind of think you have to build apps for everything. And I tried to address it a little bit as we went through it, but long story short, you don't. You could actually build a single app that makes the device operate like any device that's out there. You just lay out your display views and you do all your calibration setup on a single panel. And so in that regard, it would operate just like a device that's out there today. And then from there, if you chose to customize the apps, you have that option. But no, you don't have to build an app for every application. You could build one and use that for everything you encountered. So hope that answers the question.
Okay. Yeah, great. We also have, Matt, a couple of questions about wedge delay calibration, a request to see wedge delay, and then also any reason that we didn't show it. So can you talk a little bit about wedge delay calibration?
Yeah, sure. So for today, we were demonstrating the concept, and so we took out some of that. We also didn't do a TCG and sensitivity cal and some of the other steps that you would commonly do, really just in the spirit of time. Those particulars, we'll post some demonstrations on the YouTube channel. And of course, we'll also, open up the invitation to personally show folks that particular step. If there's something of interest they would like to see, then contact us. We'll arrange to either do a specific WebEx with an individual or come see them and show them that specific step.
Great. So yeah, we will send an email out to everyone with a link to our YouTube channel where we can post a video particularly on wedge delay calibration. So look for that coming. Another question, Dan, is in regards to overlays. Can you talk a little bit about overlays?
Sure. The current release 1.2 of the software does not yet include Weld Overlays. They will be included in the next release, in the coming 2.0 release. There's a fairly versatile set of overlays for different weld geometries and spacings on the screen and so on.
Okay.
So next, coming soon.
Okay. Great. And another question is the app available for download online, like from iTunes?
Wow, another good question. Man, I wish. No, right now there are some specific apps available on our inspectionworks.com website, and we'll continue to post additional apps up there. And then, of course, as mentioned, these apps are very small, so they can be emailed or sent or whatever. But no, we're not on iTunes or Google Play or any of those sites just yet. Maybe at some point, but But as of today, no, they're just available from us. Just contact us and we can help you build an app, or perhaps there's already one that's going to fit your needs.
Okay. Okay, and another question, can I create an app for calibration setup and block that app for only authorized people?
No, I'm sorry, that's not currently a capability. When an app is installed on the instrument, it is available to all users of the instrument. That's something that we can consider for future development, future releases, but so far we haven't encountered a demand for that yet.
Now, just to add to that, we certainly can block the app by password for any modifications, but as far as, if someone has access to the instrument and the app is loaded on there, then they would be able to run it. And again, it's another scenario could be where you have a thumb drive with the apps that you want specific people to have access to, and that thumb drive, once you're done with the instrument, you actually delete all the apps on it. So it's an empty instrument, and then the individual with their thumb drive plugs it in. A very quick operation. They actually hit the plus button a few times, add all the apps they want access to on there, and then that's what they could do. So there's ways to control it, but specifically password protecting the operation is not on there today.
Okay. Great. So we do have some more questions here. For velocity, wedge delay, and sensitivity calibration, can we perform using radius, depth, and thickness similar to OmniScan?
Yes, the radius and depth options are there, and depending on the application, whether you're doing straight shots as opposed to an angle beam sector scan, there's where we would use the thickness. So yes, those capabilities are in the instrument.
Okay. And what about then your plans? We have a question, Matt, on if GE plans to build a scan plan system within the instrument.
Yeah, actually, there's a pretty involved answer. The short answer is yes. We currently on the scan planning side, as well as on the analysis side, we have a very simple program for both of those. Actually, for the scan plan, we do not. For the analysis, we do. But we're going to do the same. So on the scan planning side, we will have an offering, but then there's some very advanced beam modeling software and scan planning software that's out there. Ultimately, we'd like to be compatible with those as well. So, you'd have the option that we offer that's available to do kind of the basics, and then we'd also be compatible with maybe one you're already familiar with. So that is the plan, but as of today, we currently don't have one.
Okay. And then a question about during the TCG calibration, the question is why there is no TCG curve on the A scan.
Hey, the short answer is that feature has not yet been implemented in the instrument. Again, coming in 2.0, especially in the conventional channel side, there's been a lot of work done around amplitude evaluation techniques. DAC and TCG are going to be available there. They are displayed on the A scan during work. The utility of the TCG line displayed on the A scan hasn't been felt to be quite as prominent on the phased array side. That's certainly something that we can add in future releases, but simply it just wasn't a high enough priority yet to be implemented.
Okay. And then we have a couple of questions then on the probes that the hardware compatibility with the Mentor UT. Can you talk a little bit about if we have a list of probes that can be on the Mentor, and then the UT hardware capability to run different types of probes.
Yeah, I guess the easiest way to think about it is the existing probes out there with either an IPEX or a Tyco style connector can be connected to the Mentor UT via either an adapter, or some of them are direct connect. The instrument itself is a 3232, so you would have that limitation as far as the number of elements. But that being said, I mean, I've connected 60 element arrays to it and run just 32 of those, and it was able to perform the inspection I wanted to perform. So as far as compatibility, I mean, you know, it's pretty much compatible with everything that's out there. It may or may not need an adapter, but we can certainly drive elements.
Yeah, just to add to that a little bit, there's I saw another question in the Q&A list about whether the instrument is pre-programmed for certain probes. We do in Create provide a list of some of the most common probes that have the native Mentor connector on them. And when you select those in the list as you're beginning to plan your app, you can select a probe and it will pre-populate the critical parameters that would describe that probe. So like number of elements, element pitch, elevation, the frequency of the probe, those kinds of things are preset for you from a database of known probes. But you can pick any probe, it doesn't have to be one that we make, and enter those parameters manually, both with controls on the instrument itself or in Create as you build the app. You can build your app targeting a particular probe from, you know, it could be from another manufacturer. So it's a very versatile system that way. And as Matt mentioned, we have adapters for the common probe connectors, like the connector we use on our phaser or that our competitor uses on the OmniScan. We have adapters readily available for those probes.
Okay, great. Then we have another question on if the Mentor UT can perform calibrations on exotic materials such as stainless steel, ink alloy, etc.
Yep, sure can. And that's just, you know, a function of
you mean to have a standard of
having the
materials.
standards, yeah, and it'll calibrate to it.
Mm-hmm. And as I demonstrated, I used the IIW block because that's a very ubiquitous block. You know, there's lots of those around the industry. If you have a particular calibration standard that's not the kind of thing you run into every day, you can build your app around that. You know, take one of our standard apps and tweak it up a little bit to describe different radii on the curves or different hole depths. All that is very easily done either on the instrument or using Create. The advantage of doing it in Create is then you have an app that's already configured for the hardware that your inspectors are going to have in their hands. So it's very easy to take, as Matt showed, one of our apps, clone it, tweak the parameters that would make it unique to the equipment kit that your inspectors use in the field, and put that on the instruments that you send out with them to inspect.
Okay. Great. Then we have a question about reference reflectors. So the question is, how can we get the instructions of reference reflectors while changing from one step to other step on the calibration process? So for example, while doing a velocity cal, take the SBH of 30 millimeter depth as first reflector and second is 60 millimeter. And if you can get this on the screen while doing the calibration.
Yes. To the extent I understand the question, so you can set up an app and Create either to have the reference values locked or be able to edit them. If you set it up in order to be able to edit them, then you can hit actually there's a button on the menu where you can change the reference values. There's also a way to set up the app where they're always on the screen. And I've actually got an app like that. which I'd be happy to share with whomever would like to use it. Just again, contact us for specifics like that, and we'd be happy to go through that specific operation in more detail, so we make sure we get the question answered. But to the extent I understand the question, then yeah, we can display it and we can change it.
Okay, so yeah, maybe we can. That's another that we could perhaps add a video to the YouTube channel on reference reflectors. Okay, and then one other question. I know we're just about at the top of the hour. One more question regarding if there's an option for sizing the defect, such as length and depth on the screen. I'm not sure that I completely understand the question.
Right. So the tools in the current active release of Mentor Instrument Code, which is 1.2, it's been out for a couple of months. The sizing tools are admittedly a little bit weak on there. There are a whole raft of new sizing tools that will be coming with the 2.0 release as soon as that's ready. You'll be able to measure length and depth both on the sector scan and on the C scan. There'll be the tools are all used, as you saw during the demonstration, as I used finger gestures on the various data views to move crosshairs around. You'll have one or two sets of cursors, and there's all kinds of measurements that can be taken between cursors or with the absolute position of the cursor. So short answer is there's a much more versatile set of sizing and measurement tools coming in the 2.0 release.
Okay. So that 2.0 release, we've referred to it a lot. I believe that's set to be released at the end of this month. Is that correct, Matt?
Yeah, subject to some changes we're actually looking at making to increase the capabilities within that release.
Yeah. Okay.
So the final date actually hasn't been set, depending on what we're going to include. But I know we are getting close to the top of the hour. I just before we ran out of time, and I know people have busy schedules and have to leave. I wanted to make sure to thank everybody for attending. I certainly want to thank our hosts, and thanks Dan for the presentation, and any questions that we haven't gotten to. I guess we're capturing and we'll be able to answer after the fact, right, Julia?
Yeah. Thanks, everyone. I want to reiterate that. Thanks for joining. We are going to have to close the call, but we will address questions that you've typed into the chat and Q&A features of the WebEx. We'll answer those with a follow-up email that'll come out in a couple of days. So we appreciate the engagement, and we will address all of those questions in a follow-up email. Okay, so with that, I think that we'll close. Thanks, everyone, for attending, and have a good afternoon or evening, wherever you may be. Thanks again for attending.